Some carbohydrates are called reducing sugars because they can undergo oxidation by transferring electrons to other compounds. When a reducing sugar is mixed with Benedict's reagent, the blue Cu2 plus ions in the reagent gain these electrons and turn into Cu2O, which has Cu1 plus ions. This causes the Benedict's reagent to turn from blue to green to orange to red to dark red to brown, depending on the amount and type of sugar. In this lab, we will be performing a Benedict's test on several different carbohydrates. We will start by adding a small amount of a 2% solution of each carbohydrate to an individual test tube. We will then add a dropper full of Benedict's reagent to each of the samples. I will then place our samples in a hot water bath for 5 minutes. Because the water, sucrose, and starch did not react, we're going to try and use hydrochloric acid to break apart the glycosidic bonds, which may allow these carbohydrates to be oxidized. We'll start by adding a small amount of each sample to a test tube. Then we'll add 20 drops of 3 molar hydrochloric acid. Next, each acidified carbohydrate sample will be placed in a hot water bath. Will the acid be enough to break that glycosidic bond? The next step is the most time-consuming. We now need to neutralize the acid using sodium hydroxide. We don't really want to overshoot the neutralization, so we must continuously check our mixture to make sure that we've added the perfect amount of sodium hydroxide to the acidified carbohydrate mixture. We can verify that we have neutralized our sample by checking it with blue litmus paper. If the paper stays blue, we know we have a basic solution and our acid has been neutralized. So we added acid to break apart the glycosidic linkages. We added a base to neutralize the acid. Now we can add Benedict's reagent to see if there are any reducing sugars present in these solutions.